Yeah, welcome back once again. My name is Victor Didoma here, and in our class today, we have another example we want to look at that has to do with the application of sine rule and cosine rule in solving problems of triangles. We have been able in the previous classes to derive sine rule, cosine rule, and we started looking at some examples already. So it is important you look out, you check out on those classes, please. It is important, and I want to use this time again to thank those of you who have subscribed to the channel. I have to show my gratitude to your gesture, okay? And then those of you who have not been able to do that, I also want to urge you to do that, because when you do, you'll be able to access over hundreds of classes, a hundred class. We have more than 100 classes been able to do, okay, across so many topics. So when you subscribe, you'll be able to have access to those classes. All right. So I urge you to subscribe, please. It's another way of supporting us and encouraging us to do more. All right. So we want to look at this question. We want to look at this question, and we want to see how we can apply sine rule and cosine rule in handling a problem like this. I will append the question here. So you look at the question while I develop the solution. Okay. All right. So as you are looking out on checking out on it, look at the procedure I have taken already in putting up a diagram that can help us to explain the question. Okay, the question says that in a parallelogram, that the sides are 5 cm and 3 cm with an included angle. The included angle is 144 degrees, and we are requested to calculate the lengths of the diagonals. Calculate the lengths of the diagonals. Okay. And if you look here, this DB is a diagonal. It's a diagonal. And you can also see with me there is the possibility that, not just possibility, there is another diagonal running this way. Let me not, so that this doesn't look unkept. So you can see another diagonal going like that. Okay, you can see that. So how can we calculate this diagonal and this diagonal? You are going to please be there so that we can be able to handle this. Now, I have in the first instance been able to put this angle here, okay? And this angle here, I'm also going to put it here. You might be tempted to ask me, why do I think that this angle here, DCB, will also be represented in this DAB here? I am going to quickly show you something. That if I extend this thing like this, I am also going to, this is parallel to this. So do you realize that this angle here, I hope you're seeing what I'm doing. This angle here is alternate to this angle here. Do you get that? So this angle here is alternate to this angle here. And if I like extend this thing this way again and extend this thing this way again, do you realize that this angle here will be equal to this angle here? And this angle are called corresponding angles. They are corresponding to each other. They are equal. Now, do you realize that this angle here, which is 144 degrees, is also equal to this angle here, which is alternate to this? You see? So I think my explanation is taken. So back to what I have been saying. That here will as well be 144 degrees. All right, back to the solving. What are we quickly going to do here to get the first diagonal? I would say calculating dB. Calculating dB. What am I going to use? Am I going to use sine rule or cosine rule? I'm going to use cosine rule. Reason: you have two sides of a triangle and the angle between them. Two sides of a triangle and angle between them. Look at it. If I apply sine rule here, you can't be able to. Time will not permit me to do that. Let me quickly go. So I am using this cosine rule, calculating dB using cosine rule. Okay, I'm using cosine rule to calculate dB. Okay, so this will be small c. So I will say small c. I will state that cosine rule. Small c squared will be equals to the letters that are here are b squared plus d squared minus then 2bd then cos capital C. Okay, so I will substitute the values. The values, this is facing here and this is facing here. So this will be small b 3 squared plus 5 squared minus 2 times 3 times 5 then cos 144 degrees. Okay, this is 9 plus 25 minus 6 times 5 30 in bracket cos 144 cos 144 gave me minus 0.8090 minus 0.8090. Okay, and this we give 5 here will be 30 34 minus 30 times, so times 30, let me check, times 30, that's 24.27. So this will become plus 24.27. 24.27. You know, this minus times this minus will give plus here. So this becomes plus. The sum of these two will give us what? 34. 34 plus 24.27 equals to 58.27. 58.2. I need to use my calculator to be more accurate than doing guesswork. So we are taking the square root of both sides now. So taking the square root of both sides, we now have, I hope this is still very visible to you. We have let me put it over here. You have c equals to square root of 58.27, and that will give us c to be equals to that side c 7.6 unit of measurement cm. Okay, so this line is this dB is 7.6 cm. Okay, and we have calculated one diagonal remaining AC, the other diagonal. But this one now, you need to follow me, because if I extract this triangle, like let me wipe here now. Can you see another triangle that has a diagonal like this? Either this or this. So now this angle here is important, and I cannot be able to get this angle here except if I can use this one that was there previously. If I can use, let me put this back again. If I can use this one from here, I can calculate, let me call here y and call here x. So from this triangle, I can calculate this y, and from this triangle, I can calculate this x. Then sum of x and y will give me the angle at D. I'm sure that is very clear. So let me move on and do it quickly. By the time I've got this, I now have two sides of it. I now use cosine rule to calculate AC. So quickly, I will say, solving for y, this time around using sine rule. You will ask me how or why. So, and I will say, because you now have a triangle that has three sides and the angle opposite to one of them. So this is 7.6 available. So I can say y using sine rule, y over sine, not y, sorry. Yeah, small y, small letter y. This is small letter y. And this is capital Y. Yes, as the case may be. Small y over sine capital Y, okay, equals to, this is available, small c over sine capital C. So we will substitute and we will have 5 over sine capital Y equals to 7.6 over sine 144 degrees. We are proceeding to getting this value, this angle here, this angle, okay? Cross multiply, we will have, please permit me, I'm going to do this in fast because this is sine y equals to, we will have 5 sine 144 degrees over 7.6, because this times this, you have it 7.6 sine y equals to, this times is 5 sine 144. You divide both sides by 7 point, you now have this 7.6, we cancel 7.6 over here and you have this over 7.6. I'm sure that explanation is clear. I just want to minimize time. So quickly, sine y equals to, so when I'll be doing it in the other case, you also follow what I'm doing there. Let me take sine 144 is this 0.5877 times 5 times 5. So I have 2.94 approximately over 7.6. So I will change this into decimal, divided by 7.6. 7.6, 0.3867, 0.3867. So it then means that y is equal to sine inverse of 0.3867. So it then means that y is equals to 22.7 degrees. 22.7 degrees. That's what we're able to obtain for here, for this place. Quickly, let me go over to the other triangle and say, also from triangle DAB, you will also observe with me that solving for this x here will require me having small x over sine x, solving also from this, solving for x using sine rule. I will have small x over sine capital X, okay? Let me change this into capital so it doesn't get confusing. This is small x, this is capital representing the angle, and this one is also capital Y, please, equals to what I'll use now is A over sine capital A. Where is this coming from? You know, the name of this have changed now from small c to, so far as we are considering this triangle, that's how it is. Okay, so it will now be small letter a over that. Okay, so I have 3 over sine capital X equals to 7.6 over sine 144. I'll do what I did here, and I'll have sine of x equals to 3 sine 144 degrees over 7.6. So I will have quickly sine x equals to, let me check 144, sine 144 is 0.5877 we got before, then times 3 to give us 1.76 over 7.6. Let me say divided by 7.6. 7.6. So I get 0.2320 equals to 0.2320. 0.2320. Okay, so you realize that if sine x is this, then x will be sine inverse of 0.2320. So we have x equals to, okay, we take the sine inverse of that. So that gave us 13.4 degrees. So can you see that we've been able to obtain these two angles that make up D? Do we get that? We've been able to obtain, you say D is equals to the angle X plus the angle Y, which will give us 22, 20. This one is 13.4 plus 22.7. Okay, so let me say plus 22.7 equals to 86.1. So this will be the angle at D is 20, is it 20, 30, 36, 36.1 degree. Okay, so we are now close to calculating the second diagonal. It's a I just okay, I just trust God that you didn't find it, so you know, I just follow me, just follow me, just follow me. So here we look at this in this way. I'm thinking of making a diagram that will help you too, but I'm thinking you are seeing what is going on there. You are seeing what is going on there. Something like this, like this, like this. Now, mine too. This is a sketch anyway. And here is 36.1 degree. This is 5 cm, and this is 3 cm, and this is the second diagonal AC we are talking about, and here is D. Can you see that? So that's exactly what we want to calculate. So this will be small letter D. So I will say solving for D using cosine rule. You see, we are back to cosine rule. That's why I did, when I was doing this derivation, I did the derivation of sine rule and cosine rule at the same time, because they are interwoven. You use them, you can use them, interchangeably. So I have to do that carefully. So using cosine rule, so I will state the cosine rule that D squared is equals to, the others are A squared plus C squared minus 2AC, then cos capital D. So A here is 3 plus 5 squared minus 2 times 3 times 5, then cos 36.1 degree. So this is 9 plus 25 minus, this is 6 times this, which is 30, then in bracket cos 36.1. That gives 0.8078. 0.807677, 78. Yeah, 78. Yes, you have to be very careful when you are doing calculation. So times 30, let's see what it will give us. Times 30 equals to 24.23. So I have minus 24 24.23 minus 24.23. This and this will give me 34. 34 minus 24.23. So I have, let me tidy it up here. Okay. Finally, I have 34 minus 24.23. 34 34 minus 24.23. 24.23. That's 9.77. So I have d squared equals to 9.77. So d is equals to square root of 9.77. So let me check the square root of that. 3.13. D is equals to 3.13 cm. 3.13 cm. Wow, it's it's a it's a very good outing, right? I'm sure that this is nice. I'm sure that the explanation is very, very nice. Please look at it again, look at it again and again, and then you can watch the video over and over so that you can be able to understand the detailed explanation. We are given a parallelogram and we are asked to calculate the lengths of the diagonals, given the angle in between the sides, and the sides are also given to us. That's the question that is given, and I'm sure that this explanation has been able to remember what we are doing is the application of sine rule and cosine rule in solving problems of triangles. Okay, and I'm sure that this explanation and this example was able to capture what we need to know in in the use of sine rule and cosine rule. The examples are not have not been exhausted. We still have so many of them that we need to still look at subsequently in our classes. So if you hang around, you'll be able to follow us in what we're doing. And the best thing is to subscribe to the channel. The greater percentage of you watch and go, this is not good. So when you watch and what we have done requires us to be encouraged, you just touch the subscription button there, okay, and then touch the like button. That's all. That's all. And when you do that, you are telling us that you deserve encouragement, and we will be our encouragement will be boosted to do more. Okay, as we are impacting the society, you are in turn encouraging us to do more. I am trusting God that when you do that, God will bless you. Thank you so much for being there.